Check one, check one.
Check, 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 check. How's everyone doing?
Fantastic.
Awesome. Thanks for the energy. I'm not sure if they're responding or if y'all are, but it's okay. So I'm Neil Hanlon. I am a potato engineer, which means that I engineer a lot of potatoes or herd them in some fashion. I am the Rocky Linux co-founder or a co-founder. There's a group of us that have founded this and are really great and a huge part of the community that makes Rocky awesome. But at work, I work for CIQ, who is one of the founding sponsors of Rocky Linux and contributes engineering time, effort, my own self. I work for them, but I spend a lot of volunteer energy and time outside of there, working on everything from helping customers to building Rocky, and that's really where I focus primarily a lot of my time. Outside of that, I am an IPv6 zealot, so if you'd like to talk about the benefits of IPv6, I am available anytime. I'm also a core reviewer for OpenStack Ansible. We're going there actually right after this conference to evangelize Rocky Linux to Open Infra. And I also recently have joined the Fedora and Nepal ecosystem to help package some stuff that I'm interested in, that Rocky is interested in for our build system, and for generally facilitating Rocky's needs as well as the community's needs of Rocky in Apple and Fedora. So I promise we'll get to it soon, but I want to talk about, or I promise we'll get to what Peridot is soon, rather, but I want to talk about first how we got here and why we're building Peridot. It helps to explain some of the decisions, I think, that we have made in informing what we're building in our new build system. So, why? Almost all of us were completely new to building Rocky, CentOS, any RPM distribution. There's a very small number of people in the entire world, I think, that actually understand soup to nuts how to build all of these things, and it kind of shows. All of the tools that we're using in Fedora and how we build Rocky 8 today is with Koji and the entire ecosystem thereof, how with Punji and Mock, Module Build System, all of these great things that are awesome tools, but they're difficult to increase the number of experts on them for what are very complicated tools when we already have a pretty small team covering a large area. So our biggest pain point really was with modularity. Modularity is a beast and it was an incredible amount of work to understand. We had a lot of help from a lot of people. Pablo Greco and the Fedora standard operating procedures have been a massive help. But ultimately, we just ran into a lot of pain in using Koji to build Rocky. We took a first attempt at this to help automate the Fedora tooling and use what we had built, use what we had learned to build. And the first thing we built was this thing called Distrobuild. Distrobuild is this portal you see over on the side. Basically, it was our first Peridot, in a way. It's kind of like the pre-alpha version of Peridot. We developed this alongside a standard called srpmproc and OpenPatch in order to standardize the patches that we were making on top of Rockies, because what we're doing ultimately is just pulling down patches, or pulling down the software from Red Hat, from CentOS Stream, patching it, potentially, and rebuilding it. When we're rebuilding it and patching it, we want to be able to apply those patches consistently and in a standardized fashion so that each time we're able to build the same thing and have consistent builds overall. Distrobuild helped us tremendously in building 8 and orchestrating all of the builds and calls to module build system in Koji, helping us understand and automate those so that we could build the operating system, and it works really well. Like we use it today to build Rocky 8, and it is consistent in exactly what it does. So it was a win from there, and we learned a lot of stuff while we were doing this. So SRPM proc, a little bit more on that. It looks like this. This is the config over here. This is for Python 3. We actually no longer need to do this patch because it's upstreamed into Python itself, which is a great win for us. We're always super happy when we can take patches that we need to build stuff and contribute them back upstream, contribute them all the way upstream in some cases to, Canonical with Cloud in it, or Grafana, lots of different cases where we're able to contribute it not just to Red Hat, but all the way upstream into the source itself and get ourselves into those packages. That's super great when we're trying to build things that we don't have to try to implement support for Rocky into those packages as well. .NET is a huge one. So going through this a little bit line by line, this adds this file to the spec, or it adds a patch file to the SRPM from our Git. It downloads all of the sources and puts them into a look-aside cache using dist-git. It's similar to what Fedora uses, CentOS uses, and it then fetches a patch repo. The patch repo is this, essentially, with the files, and we apply this patch such that each time we grab the upstream sources, we're applying it in the exact same manner, and we know that our patch is, if we're debranding something, it's catching all of the debrands that we know of. This was a fairly substantial patch, but super non-trivial patches can happen too. Like we can use patches to enable or disable flags, change out stuff in the spec files, stuff like that. And the last thing SRPM proc does while it's importing is commit and tag the result of that build back up into git.rockylinux.org. So we take the source really from git.centos.org, download them, patch them, and commit that result back up into our sources so that we can build them. We use the same thing in SRPM or Peridot as we do in Distrobuild. So a little bit more on why. We wanted to better understand and control how the build process was really architected. Koji, as I said, is a little bit hard to understand, set up, and also integrate. Fedora's been using Koji for years and years and years, and it shows. They have a lot of scripts and automation and tooling that all hooks into Koji, hooks into the Fedora message bus, and automates all of those builds. The message bus for us is not a super scalable solution that we felt that we could rely on. Authentication for it is also all Kerberos, sorry, couldn't come up with the word. And that was also something that wasn't super scalable into the cloud native architecture that we wanted to keep. Alongside that was also NFS, which I have probably some PTSD from working with NFS in the past, but trying to run builds on multiple architectures distributed around the globe with a single NFS share that needs to be always there is not the easiest thing to do. Along top of this, we wanted to add additional RBAC and transparency for all of our builds, all of our imports, and have more flexibility than what was currently enabled or functional in Koji. Peridot ultimately is our attempt to make rebuilding a distribution like Rocky and adding on top of Rocky something that anyone can do. So introducing Peridot, we built in a full buzzwordy sentence a cloud-native build system that runs on any Kubernetes cluster. That's at least the theory. We're working towards that, and the biggest pain point for us right now has been like setting it up and getting it distributed, rolled out, configured on every user's system. It uses the exact same import and build module workflow from Distrobuild, but it has native module builds without any need for an external component like module build system to orchestrate those modules. They act essentially like any other package does. To solve the NFS issue, we ripped out NFS and replaced it with a custom microservice called YumRepoFS, which is it's our attempt to make composable RPM distributions, essentially. So what we do with YumRepoFS is we store each build as its own build kind of artifact and keep all of them around, and then compose the overall repositories, which are where all of the packages belong, at build time, so that we merge all of them together rather than trying to run a single dep solve against the entire list of packages to try to fit them in what repository they go into. However, we've discovered that this has some issues, which I'll get to in a little bit. Here's a kind of quick look at Peridot. This is the build for Thunderbird. Into Peridot, we also added a full errata API. This is now fully integrated into Rocky 9 as well, so we are able to attach errata and update info into Yum repos for all of the packages. We're going to be writing some blog posts on this as well. I promised that a little while ago, but they are coming. We're just working on a place to get them, but errata is a really great place that we've been able to support a lot of users' use cases for grabbing security info and have an API that can be referenced by companies like Tenable, Nessus, and integrate those into their scanners so they can get better quality scanning information for the packages and security vulnerabilities that are available in Rocky, or hopefully fixed on Rocky. It also supports dark mode. So I want to talk a little bit about what it looks like to use Peridot from a user's perspective when you're wanting to go and build a package. Packages are configured via a catalog or multiple catalogs that are synchronized with the project. They're stored in Git, and we sync them with API calls. So we haven't kind of completed that full chain here, but the idea is that when a change happens in Git, it'll fire off a webhook so that we can sync those catalogs into the right projects and have kind of full Git ops work for configuring the project. So configuring the project's everything from this over here, which is a example of us adding our Rocky release package into a couple of repositories there. So we split different files or different RPMs go into different repositories. We have a script which processes all of the upstream sources and categorizes which repositories they need to go into. So it's a different catalog called auto catalog that contains all of those upstream packages. This strategy enables us to identify any packages that aren't actually contained in any other repositories, and we can take those and throw them all into another package repository. So this is kind of another pain point that we've experienced while rebuilding Red Hat and CentOS, that there are some packages that are just missing. They're hidden dependencies, basically, and so this allows us to push out all of those package dependencies, even if they're not required by a package in runtime. Going through this a little bit line by line, the type here is going away, but the type here is varied based on what the type of package is, and this is how we teach Peridot what package, how it needs to build a package. So if it's a upstream source, we can sync it down and do the correct import and build steps for that. If it's a module, we know that we need to do module builds on it, etc. That's all configured in the catalog, it's all configured by the user, and it can be in a single project. They can be different types, as I said, like this is a normal source package, it's in dist-git format, and everything else that we don't have here goes into our devel repo at the end of the day. This is some more project configuration. This is essentially an implementation of software collections in Peridot. So software collections are packages that kind of need to build on themselves and require them in their build route. So we added a feature to Peridot to allow these scoped packages that describe a package that depends on one or more other packages. Also allows for enabling and disabling modules on certain builds. So if you need a module enabled, you might need to set that in the config here. This also allows us to configure what packages are available in the build stage routes. So in our SRPM build stage, there's different packages that might be required. We can modify those on a per project basis for the RPM build as well as the SRPM build. A bit about how we're using it. There are several efforts right now to use Peridot, and biggest right now is all of our SIGs. So we have their cloud SIG, we have an OS tree SIG, we've got our alt-art SIG, we have a storage SIG, a database SIG, and an AI SIG, as well as an HPC SIG that have all kind of recently been started up, all using Peridot to build packages and down the road to build images and release them to major cloud providers as well. Happy to talk more about any of our special interest groups. They're kind of super diverse. I'm part of kind of all of them, so it's interesting to work with the different people involved in these and see what they want to do. Help them and encourage them not only to work with Rocky, but work with upstream projects in upstream SIGs or whatever the case may be there. This also helps us contribute back. We've had a lot of issues when building 8, but we were building 8 a while after 8 was actually built. So we were trying to build packages from 8.3 or 8.4 without having all of the package dependencies from before. So one of the things that Peridot is helping us to do is building things faster in such a way that enables us to contribute higher quality bug reports to CentOS and Red Hat when things are broken. A great example of this was Grafana a few weeks ago that we were building. We found that it had a broken test, so we were able to contribute that back up to Grafana and CentOS and Red Hat so that those builds would be fixed. We also have open QA testing, which we're working to integrate into Peridot as a kind of similar webhook type system so that we can fire off automated tests when we finish composes, when we do builds of images, when we make new ISOs, all of that type of stuff. We call this kind of our look ahead. We were working on building it actually out at the table earlier in between talks. We do this in 8 and we're working to do it in 9 as well, right? So this really is helping us to close the gap between what we're doing, what Red Hat is doing, and contribute back to that ecosystem. So how can you use it? I know when I was a sysadmin, I guess I still am a sysadmin, but in a previous life at different jobs, I always had to rebuild packages for some reason. Someone wanted a flag, it was an old package, or I just wanted an updated version of something. Peridot's really good for that, and we're working really hard to make it more accessible to users so that they can take advantage of how easy it is to patch and rebuild those packages on their system, possibly without Kubernetes being involved. Yeah, and a lot of the stuff is not current state necessarily, but where we're hoping to get it to so that you can have parity in your API and CLI and UI and use it essentially however you'd like to. So a little bit quickly now about what's next. These dates are not firm, but they're organized in such a way of our priority kind of on getting things available in a manner that will help us achieve our goals. So our RADA administration portal, we have that now. We have our RADA whole system is open API specification that you can go on our website and grab, query it, use it however you'd like it. We also have RSS, and there's been some requests for email on that too. We don't know if we're going to implement email, but if you're interested in that, come talk. The second item here for SLSA is really important for our secure boot environment. Microsoft's going to start requiring basically attestation of transparency logging for the builds of the kernels that we're doing for secure boot. And so we're going to be working to implement secure boot, or not secure boot, but SigStore signing into our keykeeper component, which signs all of our builds, and we'll also start signing the logs of all of those builds which occur. Non-Kubernetes builders, there's a lot of times where we just don't want or need to run Kubernetes to run mock, which is ultimately what we're doing. There's also some other examples there where we need to run things in emulation environments or invert without KubeVirt for image building and some other bespoke reasons, I suppose. Speaking of image building, we're going to be implementing image building into Peridot so that it's a single kind of shop for us to kick off all the builds of our images, release them to cloud providers, test them. Automated regression testing is going to be a big part of this so that we know that we're not releasing junk and can enable other people to build on top of it later. YumRepo-Fest v2. Biggest request we've had for this, and the biggest reason that we're changing it, is that the architecture we built YumRepo-Fest on essentially assumes that you're only wanting to release a single version of a package. So we aren't able currently to keep multiple versions of a package, all of the older versions that we previously released, in that repository. We still have them, they're still available, we know which ones they are, but the system doesn't support holding multiple NVRs, or multiple NVR tuples in one repository. And it's sort of a fundamental architecture change that we're going to have to essentially reinvent the wheel on what we're doing with the YumRepo-Fs. It is going to be backward compatible. We are going to upgrade ourselves and the people that we know are using it. My employer obviously is using it. But the main idea that we're working to fix is to have multiple versions of those packages and make it really clear what version of a package is in your repository, in your project, why it's there, where it came from. A common workflow that we have when we release a new package is, or a new release of Rocky, is we clone the previous version, the previous project. So we're going to be implementing also a management interface for all of those packages so that we can see the inheritance of those packages, where they came from, why they're there, and also control if we need to override something for any reason. Additionally, we're going to be adding a compose and release management integration, similar to our image building, similar to the package management stuff, but this in particular for our composes for when we release to do the kind of final release of everything and send it off for testing. So this will help us to kick off automated regression testing with our testing team. They use OpenQA, and as well perform additional tests off in cloud providers when we're building images and doing that sort of stuff. That's also going to go along really well with chat ops and webhooks, which we're integrating kind of initially just notifications for us when packages are failing to build, and ultimately we're going to work on driving integrations with Mattermost playbooks, which is our, we use Mattermost as our communication platform, and it has a playbook functionality that allows us to kick off kind of incident resolutions. So we're working to figure out how we can use that to help us as a team respond better to incidents and not be as reactive to them. Quality of life fixes, they're ongoing. A lot of stuff to the UI that needs fixing or changing, exposing logs in a better fashion, splitting out those logs how we're used to, as well as a lot of debugging and troubleshooting stuff for when packages are failing to build, helping us get the configuration that we need to reproduce that build locally, as well as possibly step into that container, step into that build, see what's going on in a live environment before throwing that away, of course. And then lastly, build automation with ordering. That's going to be a really big thing for us to be able to respond to events occurring in the Fedora message bus and trigger builds automatically when we see CentOS stream build a new package. We can go ahead and automatically build that and ultimately take that notification, and if it fails to build, send someone an alert so that we can investigate why it failed to build. And I think that is it from me. Does anyone have any questions? Not you. Okay, fine.
Okay, so aside from building packages, I had a question about building kernel.
Okay.
Is the capability there to not only build modules, but to automatically be able to sign them so that they will properly load with Secure Boot?
No.
Is
But
that an ETA?
that is going to be happening this year as part of that transparency signing. That's basically a requirement for us to continue to release Secure Boot, right? With some of the vulnerabilities that have occurred over the past couple of years in shim and everything else, Microsoft's going to be really big on that. So that's the big driving force behind it. But in general, we want to automate that from our own kind of security posture perspective. They're done right now in an isolated environment as per the specification, but we'd really like to remove all humans from that, and ultimately remove humans from the entire process as much as we can. Not just for a saving all of our time thing, but Rocky was launched kind of right in the midst of SolarWinds and that whole thing with supply chain. So that's always in the back of our minds, or maybe even the front of our minds, to think about the software lifecycle and the security of that.
So, kind of to follow up on that, when you get the traceability of the software that you obtain and your entire build process is all auditable, because as part of that, it's the executive order from Biden that has all types of rules for software quality and for supply chain stuff in light of SolarWinds.
Right.
So, will this help? You know, can you describe a little bit about some of the features that will help with that?
Yeah, absolutely. At a minimum, what we're going to start trying to do is signing the transparency logs of signing logs with like SigStore of what the build is doing. Right now, there's not a mechanism in like RPM to validate any of that, but we are looking essentially to also publish a ledger, basically, right, of what the cryptographic signature of all the packages that we have, so that we can be compliant with those sorts of orders and also allow our users to better secure their systems. Like, GPG signing exists. It's not the greatest thing, as we all know, and we'd like to also work upstream as well with the signing that we're doing to help or to ensure that we're implementing it in like the standard way. If that involves defining the standard, helping to implement it, whatever it is. I know that I think DNF5 now supports like SigStore or something. I think I'd heard that, but yeah, it's a bit of a hard thing too, because we're on Rocky 8 and 9, and we're not necessarily going to get the newest features of those things. So we'll have to do some thinking about that, but we are planning to sign all of those things in a publicly verifiable way. Blockchain, yeah. No blockchain. Cool. Find me after class. Thank you very much.